Welcome to this Minikube and Kubernetes tutorial. So in this tutorial, we are going to do the following. We will go through the process of installing Minikube. We will then install kubectl, and I have prepared an application here, which we have used in the last video, where we use Docker and Docker Compose. So if you want to see the application or how we created the application, you can just watch the last video, or you can just download the source code from the Github repository. So the application is pretty simple. It is just a simple front-end application that fetches some data from a server and displays it. And our server, everything it does is just return this data here back. So what we are going to do now is set up a Kubernetes cluster locally on our machine. We are going to build out the Docker files here. So we are going to build out Docker images, after which we are going to push those Docker images to GitHub. And when those images are on GitHub, then we are going to pull them, create pods in our Kubernetes cluster, and just run the application. So let us start. First of all, we need to install Minikube. In order to do that, just download this link here. After you have downloaded the link, you can go to your downloads folder and just follow the installation here. So it is a pretty simple installation. You just follow your standard next processes. So it's pretty simple. If you want to install it on Mac OS or Linux, you can also do it with script commands, so that also shouldn't be a problem. The next thing we will need to do is set up kubectl. So kubectl is our CLI, our tool, how we are going to be able to talk to our Kubernetes cluster. So everything that we are doing, every command that we are issuing, we are going to do this over kubectl. So in order to do that, you first need to download it. So here for Windows, we can just download the link here. After you have downloaded it, you can do the following. You can put it in any folder you would like. So for example, let's say we download the file here. We could just put the file in our C folder here. And then the last thing we would need to do is set up our environment variables. So let us go to our environment variables here and go to path. And then we would just need to add a new path here. So I have added this in our bin folder, but the process is the same for whichever folder you choose to use. Okay, so this is everything. After you have configured this, you can run kubectl to test if it's working. Here I have just pushed the code to GitHub currently. So you can just use kubectl and you should get a message like this. Great. Now the next thing you need to do is start our Minikube node. So in order to do that, in Windows you need to run in under administrative mode. So you need to type in PowerShell and run as an administrator. So that's what you need to do, and that's the reason why I have opened another window here to display that. Then you can just start your Minikube cluster. So I have started mine already here, so I can just type in Minikube status, and it should be able to list the state of my node here. It takes like a few seconds to get a response here, and it says it is running. But if you are running your cluster for the first time, you have either two options here. So Minikube start Hyper-V. You can use Hyper-V to start, or you can use some other virtual machine like VirtualBox. So that's basically how you start for the first time. So that's how you would do it. So you would say Minikube start driver and specify the driver as Hyper-V. So you could also have a few problems there saying that Hyper-V is not enabled or something like that. So for that you would need to set this up in your BIOS settings. So let's return to our code. We have our Docker files here, which you can either see on our Github repository or the last video that I have posted on this channel. So now it's time to create our Kubernetes folder. So a common way to call it is K8S, so which stands for like a shortcut for Kubernetes, where K is for like the first letter of it and S the last, and 8 stands for the 8 letters in between. So that's a pretty interesting approach. So what we need to do now is create the following. We have our client and we have our server. So we need to create a deployment file. And that deployment file is going to create the pods of the images that we are creating. And why are we using a deployment file? So a deployment file is very handy because if you want to update something, we just change it in our configuration, hit apply, and we can see the updates there. So let me show you exactly what I mean by that. So we have our Kubernetes master here, which is our master node. And we have a node here. And in this case, since we are running Minikube, Minikube is going to create one node for us here. So if we were running in production or something like that, we would have multiple nodes here that can communicate with each other. And everything that we do, we communicate through our CLI, which is kubectl. Over kubectl, for example, we can use the command apply, which is going to apply a file, a configuration file, to our master node. And that master is going to do what that configuration says. So for example, let's say we say in our configuration that we want to create 3 pods, and those pods are going to have some containers here or something like that. And a pod is the like minimum thing that we can create here. So a pod is we can't create anything smaller than a pod. So we can't create single containers. We can create pods that contain containers. Okay. And our master is going to take care of this. So if we use a deployment, then we can change this. So for example, let's say we change a port in our file, we change the image we are using, we change something else, then we can just say to our master, apply it, and the master is going to take care of it. But on the other hand, if we were using pods, then we couldn't do that. So then we would need to destroy the pod and create a new one, which, as you can imagine, is not as nice as having everything stored in a file. So this is the difference between an imperative and declarative approach. So the declarative uses files, and the imperative, we issue commands that are going to take care of the changes. So let us create our files now. We will need the following files. So we will need client deployment, as we have mentioned. We will then need server deployment YAML file. We will need server cluster IP service YAML file, and we will need a client cluster IP service YAML file. Okay, so what are those files actually? So when we create our pod here, so let's say this is our client and this is our server. So they need some way of communication. So we need to attach some type of communication to them so that they so that we have certain ports and mappings that we can access. So what does this mean? So let's say our client is here and we want to communicate with our client. So we need to configure the network configuration here so that, for example, our client can talk with our server and that we can access our client from the outside world. So this is what those cluster IP configuration files are for. So let us first create our deployment. The first thing we need to specify is the API version. And different API versions are going to have different elements. So in Kubernetes, we can define kinds, so types of services that we are creating. So here we are creating a deployment. So the kind is going to be deployment. Then we have metadata, where we are going to specify our name. So this is going to be our client deployment. Then we give certain specs. So now we can specify how many replicas we want to have. We want to have one replica. We have a selector that is going to match labels with the component web. I will explain what this stands for. And then we can specify our template, metadata. We are going to have labels, component, web. Then we can specify spec again, where we can specify our containers. Containers is an array, so we will going to have this little hyphen here. We can specify our name. It's going to be the client, and our image. So our image is going to be my Docker Hub username, client, example, and I'm going to specify a version. Let's say version 10. Okay. One last thing is to specify our ports, and we need to specify our container port, which we are going to use 3000 for, because our React application in here is running on port 3000. We wouldn't need to actually use 3000, but I'm going to use it since it's a pretty common port number. Okay, now I'm going to create the cluster IP file, and then I'm going to explain what actually all of this does. Okay, I actually wrote this in the wrong file, so now it should be fine. And here inside of our IP service, I'm going to specify the following options. And don't worry, I will explain every line what it means. So here we are specifying a kind of service, metadata of name, client, cluster, IP service. And it changed the service to a capital one. So now we again give our specification here. We are going to use a node port. We are going to have a selector of component web. And the last thing is our ports. So ports are going to be, again, as you can see, it's an array. So we're going to have a port of 3000, which is going to have a target port of 3000, and we're going to have a node port, not a capital N here, which needs to be a larger number. Here we're going to specify 31,515. We need to specify a number, I think, between 30,000 and 35,000 here. So, and use only in development. So I will explain everything now. What have we done here? We have created our template, and we have the option to add metadata, and inside of our metadata we are adding a label. In this case we're having the label web, and now we need to match that label here in order to attach this here. So this is our component web. So we need to attach this configuration here to our client deployment. So as you can remember, this is our service where we are going to specify our ports, and this is our client here. And we need to attach those. We need to have some type of connection between them. So here we are specifying a node port, and you should specify a node port only in the case when you're developing stuff locally. Why? Because a node port is accessible from outside this node here. So the node port 31,515 is accessible from the outside world, so we can directly communicate with our pod here. This is something that you don't want to have in production, of course. You want to have your entire communication over a load balancer or Ingress communication here. So that's the way how you would communicate with your nodes. But for development, it's fine, and we're going to use a node port since the complexity would be much larger if we had to configure an Ingress configuration right now. So our port represents the port at which our service is accessible, and the target port represents the port of our application inside the pod in which it is running. So our React application is running on port 3000. We are making the application available on port 3000. We could have used any other port here. And node port, as mentioned, is going to make this available from outside our entire node here. And our client deployment file, we are specifying containers here. And that container, we give it a name and an image. So this is going to be pulled from Docker Hub. So we can just specify it like that. And it's going to go to Docker Hub, find the image and pull it from there. And we specify our container port. So now what we need to do is configure our server deployment, which is going to look pretty similar to this one. So I'm going to copy this and change it a little bit. So this is going to be our server deployment. We are again going to have one replica. We need to change the component here to server, and keep in mind that this is a key value pair. This could be whatever we would like. So we could name this like blah, blah. So this would work as well. But this is a common way to call those components. So again, we specify our server here. Our name is going to be server, and that this is going to be our server example here. And we want to make this available on port 5000 since our application is running in port 5000. Now let us copy this here and paste it inside of our server cluster IP. Now we need to specify server again, and we are using port 5000. And for this, we're going to use 31516. So in our client component here, we are accessing the pod from outside the world. So which is a complete anti-pattern. So you wouldn't do something like this in production. You just can't do something like this in production. But the reason I'm doing this here is so we don't have to configure our Ingress controller, which would be a much more complex tutorial. If you would like me to create more tutorials on this topic, then write me in the comments or head over to noveltechmedia.com and check out the tutorials over there. Or maybe contact me over there and give me recommendations what you would like to see next. But for this example, to keep it as simple as possible, I'm accessing the port like this. And now you have probably noticed what this IP number here means. So this IP number is the IP number of our Minikube cluster. So if we type in Minikube IP, then Minikube is going to give us out the IP it's running on. So we can't access anything of this on localhost. This is running on its designated IP address. So far so good. We have configured everything here. You always need to take care about those indentations if you have misspelled something and so on. So far so good. Let me check this once again. So this is a service, node port, this is our server, this is our client, web. Seems fine. I have also created a Github repository here where you can see all the commands. So what we need to do now is build our images in order to be able to push them to GitHub, to Docker Hub. And I have like all those commands on the GitHub repository where you can check everything out. But let us create the images right now. So we are going to call docker build. We are going to tag our image as following: client example. Now we are going to give it a tag. In this case, we are going to tag it with version 10. We are going to provide our file. So this is going to be inside the client folder, Docker file. And also we need to provide a context. So the context is inside the client folder. So hit enter and the image should be created. So remember, then when we change something, we are not going to run npm install again. We're just going to use the cache. So this has created quite fast. And remember also that I ran this command already once. So the next one is going to be our server. So client, change client to server. And now we can do docker push your ID, and also don't forget the tag. So this is going to push our image to Docker Hub. And now again, let's do the same for our server. So if you don't have a Docker Hub account, just create one quickly. That's really going to take you only 1 minute. And then you need to log in. So you can just do docker login or docker logout, and then this push command is going to work out of the box. So what we need to do now is run kubectl, apply, file, and we can specify our folder here, which is our K8 folder. And when we run this, everything is going to be updated instantly. But it looks like we have made an error here. It seems we have made an error here. So deployment. So this service obviously does not exist. So it should be deployment. So keep in mind that copy pasting those things is not the best option really. But since I wanted to keep the video as short as possible, I have just copy pasted it. Okay, we have configured our deployments, and we still have few problems here. So fill metadata. This doesn't exist obviously. So it should be metadata and metadata. Okay, let's run it again. And as you can see, we've got 3 out of 4 now. Okay, the port is already allocated. Okay, this is probably because I have run this on a different cluster. So let's use port 3517, and this means that we also need to update the port right here. So let's run it now again, and now it says deploy. And when we change something, keep in mind that we only need to run this command, because all the other files were unchanged in this case, and they were just ignored. And when we changed the file, it said it was configured. You also need to use tags, because if you push it to GitHub under the if you push it to Docker Hub under the same tag, then you're going to have the problem of not being able to update it, because it's not going to see it as an update. Let's check out our application now. So as you can remember here, we have outputted our IP address of our Minikube cluster, Minikube node, and let's hit that up. So it works. This is our client, really nothing special. And it is pulling this data here from our server and displaying it. So as you can remember, our server is exactly responding with this data here back. So it seems to work. If you want to update your cluster, you can use the declarative method and just update those files here and hit apply, and your changes will be seen. One more thing I wanted to mention, when you are accessing a new image, so for example, I have deployed our v10 image here, and I have just changed to v3, for example, to pull it back. But you need to remember that you every time need to change this here. So if you, for example, have a CI deployment pipeline or something like that, you will need to have a method in which you are updating those versions here. So if you go to our Docker Hub version here, you can see that we have pushed client example and server example up to our repository. And if you go to tags, you can see all the tags that we have pushed here. Okay, so far so good. Our application is working, and it is accessible from outside our pod. So the next step you will need to do is configure an Ingress controller and use cluster IP addresses instead of using our node ports. So I hope you found this tutorial useful, and Kubernetes is something you understand 5% more today. So if you're interested in learning more or have more recommendations, just leave comments, head over to noveltechmedia.com and maybe check out some courses there. So thank you so much for watching. I really appreciate it, and see you in the next video.